Hey math kids, today we're going to talk about acceleration, and let me just draw a diagram real quick. Okay, so if we go from displacement and we take the derivative, we get velocity, and if we take the derivative again, we get acceleration. Okay, so this is if we take the derivative, so differentiate. Okay, and then if we integrate, it goes the other direction. So I guess I should do some arrows. So these are integrate. Okay, and we just want to remember how to go back and forth between different pieces like that. Okay, so we have a particle that moves in a straight line with position relative to the origin, and we're given a displacement function. It looks like that. And it's measured in centimeters. And time is greater than or equal to 0. Okay, so it says find an expression for the particle's velocity. So to find the velocity, we just take the derivative. So v of t is going to be 3t squared minus 12t plus 9. All we had to do is take a derivative. We're done with that. Okay. Oh, it wants acceleration as well. And so, let's see, wait, what does it say? Find an expression for the particle's velocity and acceleration and draw sign diagrams for each. Okay. So acceleration looks like this. We're going to get 6t minus 12. Okay, so if we factor the velocity, we're going to get 3 times t squared minus 4t plus 3. And then if we t factor that, we get 1 and 3. Both are negative. And so this becomes 3 times t minus 1 and t minus 3. Okay. This one we can factor, and it's just going to take out a 6, and it's going to be t minus 2. Okay. And so if we set up a sign diagram for velocity, we're going to have a 1 and a 3. And we pick our values, so 0, 2, 4 for different regions. If we plug in a 0, so this is positive, so this doesn't really matter anymore. But if we plug in that, we get negative. Plug in there negative. Negative times negative is positive. Plug in a 2, that's going to be positive. Plug in a 2, that's going to be negative. And so overall it's negative. Plug in a 4, positive. Plug in a 4, positive. Positive times positive is positive. So there's our velocity sign diagram. And then our acceleration sign diagram. Our point of interest is just 2. Also, anything below 0 we don't actually care about. So over there. Okay. Now, if we, let's see, our points of interest, I'm going to do 0 and 3. So we plug in a 0, that gives us a negative. Negative times positive is negative. Plug in a 3, that's positive. Positive, positive is positive. Okay, so we ended with that. Now, find the initial conditions and hence describe the motion at this instant. So initial conditions are just when we plug in 0 for all of these t's. So if we plug in a 0 for s, or for the t's in s, we end up with a negative 1. If we plug in zeros here, we end up with that 9. So v of 0 is 9. And then a of 0 is going to give us a negative 12. Once again, I plugged in 0 for all of the t's and saw what was left over. Okay. And then we just need to make so when it begins, we are 1 unit left, because -1 tells us where we're at. We are traveling at positive, so we're traveling in the positive direction 9 centimeters per second, because this is a +9 velocity, and we are accelerating, or you could even think of it as decelerating, at -12 centimeters per second squared. So we're slowing down, okay? All right, the next thing we need to do, find the position of the particle when it changes direction. So we're going to go back to our velocity, and we want to check 1 and 3. We changed directions at 1 and 3 because our velocity changed signs. But then we take those numbers and we plug them into the position because we want to know where it was at. So if I plug in a 1 for all these t's and then simplify it, I'm going to get, just use a calculator when you do it, but I'm not going to go through actually doing it. We get a 3. Then if I take a 3, plug it in for all these t's, use a calculator, we end up with -1. So those are the positions when it changes direction. Now it says draw a motion diagram. So to do that, I'm going to zoom out. We'll just do that, I guess. Okay, so we're going to draw a motion diagram like this. It looks like the furthest to the left we go is -1. Let's see, 0, 1, 2, 3, 4, 5. And so when we start at -1 because that was our initial position, and we're traveling in the positive direction, and we change directions once we get to, or after, let's see, after 1 second we're at 3. And so at 3, we change directions, and that happens at t = 1. And we change directions until we get back to -1, because at 3 seconds we're at -1 again. And then we change directions right there, and we switch back. So we're going this direction, then we go this direction, then we end up going that direction as far as we know. Okay? And then find the total distance traveled in the first 3 seconds. So this one was t = 3. And so we go from -1 to 3. So from here to here, and that's going to be a total distance of 4. And then from here to here, we travel another 4. And so the total distance is going to be 8. Okay? Now I'm going to break this into 2 videos, and so calculator.